Okay, so hello everyone. Now we are going to talk about the projectile motion, and in this first video I was just thinking to check out the basics, and later on we are going to resolve some examples. Okay, so first of all, I'm trying my best to draw a trajectory. Okay, so far so good. Okay. Oh, it's a masterpiece. Well, we know that there is an alpha. Okay, if you prefer, it's a theta. But anyway, I just got used to it to use alpha. Well, and we also know that at this trajectory has an h high when this trajectory is on the highest level from the surface, on the highest point. Well, and usually, of course, we need some kind of information about our about example to resolve it. For example, most of the time they can give you the initial velocity. I call it V0 or VO. V is velocity and 0 O because at the starting point. Well, we both know that if there is a vector, because it is a vector, you can define it as the sum of two different vectors. Anyway, you may ask that why should we do that? Because, for example, our object can be here, depends of the time. It's a function of time when where is our object. Let's say now it's a ball. Well, and why I'm drawing this? Because if we just know that our starting velocity, our starting speed, that how can we know that at this point or at this point, what about our velocity, our speed? So we cannot tell. And why is that? Because this movement always, come on, okay, sorry, always has two components. We need to know about to define their sum. So we just cannot make any calculations with this at this example. Okay, I hope I was clear. If not, well, feel free to ask. Well, now this is the horizontal. I'm trying my best again, and this is the vertical. So of course, we use this method. And I'm sorry, I'm not really good at drawings. I remember the high school, I was just almost kicked from the drawing class because I simply I'm not able to draw. Okay, still in this level is still okay. Well, and still we know this is the alpha, or the theta. Okay, and what can we see now? We have two components. Let's define it using our alpha degree. This is VO times cosinus alpha. And what about the other one? Well, VO times, I say, sine alpha. Yeah, sometimes my English is not the best, maybe because I'm not a native speaker, but I'm trying my best. Well, yes, I said it cosinus, but it's cosine. Okay, anyway, maybe I think you understood it. Well, now we are happy. We have these two components describing our original vector. Okay, why it's good for us? Because now we know that this part is a horizontal movement, horizontal motion, and the speed is constant. And why is that? Because imagine that here's our object, now it is flying. What are the forces affecting this object, this ball? Only the gravitation. Okay, now in our special case, now there is also a fraction from the air, but now we are not adding to this force to our calculation. Later on, maybe we will. So now the only force which has an effect to our object is the gravitation, nothing else. So it means this one, and still we have this one. Well, as we can see, without the gravitation, without this force, our object would just fly off the planet. Why is that? Because what is the sum of our two vectors now? We can just something like this. And what about here? Really just something like this. Why I'm drawing this? Because okay, I just made a mistake. Because it has to be much more longer. Okay, not really correct, but it has to be much more longer. Because of course our speed, the sum of our speed of these from these two components has to be the fastest. It means that only the gravitation's vector is going to be longer and longer. It means stronger and stronger. And how come is that? Because at this moment, right here, it's just here, oh, maybe I should just mention it, here the gravitation force has no effect, because now at this point our movement is just parallel with our surface. So this component, the vertical component is 0. So here the speed exactly the same with this one. Now moving further, here already we got the same vector, and here we go, the gravitation starts having effect like this. Here it's now much longer. Of course our speed is faster, and here our speed is the fastest. So it means that without this force, not just for example in the space or in the space, that's why if we throw away something, it's going to fly forever. Because okay, I mean, if the, okay, don't make things complicated. So that's why this speed, our horizontal motion, is constant. Well, I hope I was clear. If not, free to ask. Okay, this is my slogan from now. Well, let's check out something. First, what is the time from this point to this point, and from this point to this point? Okay, maybe as you can see that this time has to be equivalent with this. Okay, how can we calculate it? Good for us. We just defined the vertical component of our VO. And how do we calculate? If a motion is vertical, V equal minus G times T. Why it's minus? Because it would be plus A. You know that A means that well, okay, now I don't know, it doesn't come into my mind. Well, A is the acceleration, but here this acceleration is special type because it's G, and our object, after we dropping it, it's going to be slower and slower, so that's why it has to be minus. Well, we want to define the time at that point. It means our final speed equals our starting speed minus G times T. So we know that our body just stopped moving here, I mean vertically. Horizontally still moves, but here this is the highest point, this H. So vertically stops here, so that's why the speed is 0. Okay, G times T. Okay, so as we can see, G times T equals V0, so T equals G, and this is the time which the body, this object, needs to get to the highest level vertically. Let's name it Ty, because okay, it's not a secret, this is X direction and this is Y. Okay, oh sorry, well, still. Okay, let's say what's the total amount of time. Let's say t like time total Okay, if this goes up, has to goes down. So time is there, but the time needs to get there is exactly the same time needs to fall down and hit the surface. So that's why 2 times ty. So let's say like VO. Okay, and don't forget, now we are not just using the VO, because we are using the VO times sinus alpha. So let's write it. 2 times V0 times sine alpha, of course, G. Okay, we know the total amount of time which needs from here to get there. And why? Because just made the calculation that the time needs to go up and be multiplied by 2. This is the time up and down. So exactly when the body, the object, goes down, hit the surface, it has to be here. Well, like something like this. It goes up, and like goes down. Okay, I think it's clear. Well, let's define the distance from this point to this point. How to do that? We just mentioned the speed here is constant. So S equals, now we are talking about x, and let's call it max, the maximum distance from here to there. Of course, we use our V0 times cosine alpha times the total amount of time. So 2 times VO times times sine alpha and G. Okay, this is, okay, we can see VO the second power, VO squared times 2 sine, okay, 2 sine alpha cosine alpha over G. Okay, this stays, and this is 2 times sinus alpha times cosine alpha. You can check it out. It's a trigonometrical equation. It means equals sine 2 alpha over G. Okay, this is for now, and our next video we're gonna check the maximum height what this object can reach. So it's gonna be the Y max. Okay, see you later.